All right, everybody. Thank you for attending again. Now we've got Dewey talking about some of the stuff that he's working on. I met Dewey 2 months ago when he was doing a presentation down in Cambridge for the guys at AWS, and I mean it was me and a couple of other users and mostly internal AWS people just oohing and ahhing over this. So very excited to have Dewey here today.
Thank you, Chris. So I'm talking today not so much about the technology of moving into the cloud, but the people and the process of the companies. As we all know, there's a cliche that managing software engineers is like herding cats. So how do you do this in the cloud? It's a different environment. I am a consultant. I've worked with a number of different companies. This talk is largely drawn from one particular company that has a reasonably large deployment. So public clouds give developers a lot of unprecedented power. I think in the last 5 years, the most common way someone moved into the public cloud is a developer says, "Hey boss, give me your credit card and I'll have a machine up in 5 minutes." Problem is, the other cliche, with great power comes great responsibility. You get into a cloud, you don't really have a lot of management there, and it can drive the ops people nuts if you actually move into production in that environment without some more process, more management around. So how do we do this? First of all, who am I? I was actually a distributed application developer, JGW architect for a number of years. Started accidentally doing DevOps before DevOps, just out of self-defense. A few years ago, I kind of wandered into the production side. People just started saying, "Hey Dewey, come help us with this. Hey Dewey, come help us with that." And so I built some private cloud for dev test. I built some private cloud for big data prod. And now I'm pretty much all in on public cloud. The company environment here, first of all, they have a policy that no one talks for the company. So I'm not speaking for this company. The slides don't mention this company. This is an old version of PowerPoint, so the text is under the picture. There's no information in my presentation that is not otherwise publicly available, released by this company, whoever they may be. Who they are is they're a major gaming company. They have multiple major gaming titles, AAA titles. They have a history of massive multiplayer online games, and they're now all in on mobile. I'm going to talk about what we did at this company, what we're currently doing, and then a little bit of some ideas for the future, how we might improve things in the future. So as I mentioned, traditional MMOs, Windows servers in a colo facility. I've used Windows for a long time. I don't have anything particular against it, except it's large, expensive, and difficult to automate. So at this point, we're heavily invested in Linux. Also all the buzzwords: mobile, cloud, Mongo, Docker. Love Docker. Don't have servers that last a long time that we have to care and feed and take to the vet when they're sick. These are not cats, these are cattle. Our goals: 100% uptime. Players want to play games. This is where it starts getting interesting. I came from an environment in more of the commercial development and the SaaS space. And wow, you think bankers get upset if they can't access their data. They've got nothing on gamers. Right? Something goes down on a gamer and all of a sudden the forums explode and you are Satan's assistant. We don't want to have patch days anymore. MMOs traditionally would have, we're down for maintenance, it's patch day. Maybe we'll be up around 5, hopefully, or 7, sometimes 8:30. That's not a pattern we wanted to carry forward. And of course, everyone's goal is you want profit. Bring in money, don't spend money, what you've got left in your hands is profit. Scale. Whenever I'm going to one of these presentations, I always want to know, is this relevant to me? Sometimes I see presentations about toys, it's like, great, that's way too small to use in my environment, or vice versa. Someone has a huge sledgehammer and I just need to swat a fly. So this is the scale I'm talking about. We have hundreds of thousands of dollars of monthly spend in public cloud. We have about 500 terabytes per month of transfer. Now, a fair amount of that is internal transfer between networks, but a fair amount of that is external, going out to clients. The peak I've seen for a single title was about 12,000 transactions per second. This is a title that rolled out worldwide in 24 hours and actually hit the entire continental U.S. at exactly midnight one night. So that was quite an interesting server load to go from nothing to amazing in the space of about 5 minutes. We have around 1 petabyte of storage. Not all that much. It's enough to care about. We're not a big data company. And around 5 billion IOs monthly. So again, it's that load pattern that I've mentioned. It's not something you see in traditional SaaS. Traditional SaaS, particularly for a small company, a startup, you're trying to get users. You release and you've got 10 people, and if you're doing a really good job, it ramps up exponentially. Games are the opposite. Release day is the largest user base you will ever see, and it ramps down from there. The idea is you want it to ramp down slowly. The interesting thing here is that you have to be able to scale out of the gate. There is no time to get it right after release. If you lose a user right now, if they can't log in, they're probably going to go play another game. Maybe they'll get back to you tomorrow, maybe not. So there's really a high premium on, we've got to have this playable coming out of the gate. And again, this is not something that historically was done terribly well in online gaming. That's one of the reasons the gaming company came to the kind of the commercial SaaS space and started looking for people with commercial SaaS experience instead of game developers. Platforms. As I mentioned, we're heavily on Docker. We typically run that on CoreOS or Ubuntu, depending on some other requirements. We have some Red Hat in the mix. We have MongoDB. We have a lot of application written in Python running on Nginx. We have some Elastic MapReduce. We actually use a fair amount of the Amazon catalog. Some years ago, we were trying to be hybrid capable, our data center versus public cloud. And I think about a year ago, just abandoned that entirely and said, no, we're all in on public cloud. Let's not try to support multiple things. One thing I did not mention here is we also make heavy use of Golang. And get a lot of advantage there. Again, I'm not really talking about the technologies, but this is what we've used, what we have experience in. You'll know that Windows is missing here. We really don't do a lot of this with Windows. I was at a DevOps Days a couple of years ago, and the DevOps on Windows breakout session was about 60 people kind of staring around, looking at each other, confused. It was not a lot of activity in the space. There is some interesting stuff, Docker on Windows, which I have not personally played with, but in general, Linux is far ahead on the DevOps space. So as I mentioned, we have a very strong Phoenix server pattern. For those of you not familiar with this pattern, that means if something goes wrong, you burn it down. You don't try to fix it, you don't try to repair it. You do care about diagnosing it, because you don't want it going wrong again. But that particular server is kind of irrelevant to you. Burn it down, replace it, or better yet, let your system automatically recognize that it needs to be replaced and put it back up. Very little manual intervention. So, the interesting thing here to me right now is the process or the social approach for this. One, we must be scalable in people. When you're in public cloud, technical scalability is a lot easier. There's this great machine that Amazon runs, you put money in, you get computing out. They're happy to have you put more money in. So if worse comes to worse, you can turn the knobs to 11 and get more compute, more storage, more technical resources. I can't do that with people. I can't go out and say, yes, I need another 12 engineers that already know my system, and I need them by tomorrow. So we need to design the system that works really efficiently for people. At any given time, we're probably working on 3 new game titles. We've got one that's about to be released or has just been released and is getting active development. We've got another one that we're staging up for release, and we've got a third one that's kind of speculative development. Let's experiment and try to make a cool game. We also have old games because we like that long tail of people still paying us money. We also have services we support for the larger company. This particular company is actually one division of a much larger company and does provide some services for the larger company as a whole. There's a lot going on. Our major goals here are don't create a bottleneck in the process. I've talked to a number of people. How long does it take you to get a VM allocated? About 6 weeks. Sometimes it takes 2 months. That's not acceptable. And again, that's where you get developers whipping out a credit card, going to the cloud, and doing it completely out of band. There are too many controls to get least privilege right. I don't try to lock the developer down to just what they're doing today, because I don't know what kind of wild idea they're going to get tonight while I'm asleep. I realize that makes me a bit of a heretic, and I'm going to talk a little bit more about that. But instead of trying to get least privilege right and make sure developers can never, ever do anything they're not supposed to, we focus more on validation. So if they do it, we want to find out about and have a conversation. Why are you doing this? What are you trying to achieve? So what's interesting about this? Policies. Yes, I really should have used my own computer to display screen. Policies are great, but they change over time. I might have something new that comes up. I might read a new article. There might be a new vulnerability or a new attack in the world that I need to respond to, and I don't just need to respond to it now for the future. I need to go respond to it for all of the hundreds of instances I've already deployed, all the APIs I've already deployed. Really hard to get right up front. Even if I have perfect information right now, next month is different. There are always exceptions. I have hundreds of VMs. If I've got 1% exception, oh, there's 5 or 6 right there. And odds are those 5 or 6 are not trivial VMs that I can ignore. They are important to my production delivery. So the other thing is we're all in on AWS, but other cloud providers are similar. The space of AWS permissions, if anyone has gone and looked at IAM policies and tried to create an IAM policy, there are handfuls of dozens of services, each supporting at minimum 4 different operations, often dozens of operations. Then you get into conditions on all the policies. Then you get into worrying about which resources support which conditions. The space, the complexity of this is absolutely huge. I'm going into this with a small central cloud ops team. We could spend the next 20 years trying to get it right, and it wouldn't be working for next week, much less what we can do in a week. So instead of dealing with all of those permutations, we measure what we care about. Oh, we're not supposed to see this? Great, let's measure for it and let's report on it. What we care about has changed over time. It always does. Today there's a new vulnerability, tomorrow there's going to be a new production title that behaves differently, and I care about something different. So I'm going to trust my developers to do the right thing. I spend a lot of time communicating with them, and then I'm going to verify that they're doing the right thing. And incidentally, this works the other way around. They also trust me, and they also verify what I'm doing, and that it's going to work. So it's really a cooperative environment. We're trying not to gate it. The old 15 years ago, there's a wall, developers throw it over the wall of production. Does not work. So we're putting power in the hands of the developers. What does that mean? First of all, we're not gating the productivity of the developer on the fine points of policy. No, you cannot expose the customer base on unprotected HTTP. Everybody knows that. That's a pretty hard policy. We don't have to verify after the fact. Oh, you have this one application port open secured by a particular authorization token technology? Great, we can talk about that. I hadn't actually gone and scouted that out in advance. I'm glad to know you're now using it. Let's figure that out. So one interesting thing about the developers is they actually know what they're doing. They have the expertise in their domain. I am not a game developer. I develop lots of other things, but not games. They have. So they have the domain expertise. They also know how it works, and so I want to make them responsible for making it work. Put the pain where the control is. If I'm experiencing the pain and I can't change the code, I can do nothing to fix the problem. If they're not experiencing the pain, they have no reason to fix the problem. So we arrange for them to experience their own pain. Trust me on this one, developers do not like to get up at 3 in the morning. They probably just went to bed. So if they have to get up at 3 in the morning to fix a problem, it won't be very long at all before that problem does not occur. Stuff gets automated. We like automation because it is scalable. Not only do I not have to do anything when stuff is automated, I don't have to pay attention to it the way I did before. Server goes down, something's going to pop it back up. Not a problem. What do I care about? Hey, server went down last night. That's interesting. I don't have to be watching in the middle of the night quite as badly. What I need to watch for is the server went down and didn't come back up. That needs to wake somebody up. So you're still paying attention, but it does make things much more scalable. So our approach, I mentioned that we decided to go all in on cloud. And if you'd like, after this, we can have discussions of private cloud versus public cloud and costs and capabilities. Happy to have those discussions. The decision here was, we're going public cloud. That's it. We have multiple accounts in AWS, a couple of dozen right now. One of those is designated for the central services. So rather than have an ad hoc mess of everything linking to everything, we have a central services account. Everything links to that. If there's a centralized service, it lives in that account. All the other accounts are for a particular production instance, for a gaming title, for a particular piece of functionality. All environments, dev, QA, performance test, staging, production, live in different virtual private data centers in Amazon. Again, they all link back to the central services. All of these accounts look pretty much the same. You can say, well, I've got 24 accounts, but really what I have is one account 24 times. They all look very much the same. I manage them all the same, with the same tools. I mostly apply the same policies. What is the dev team responsible for? Well, they obviously dev their code. They develop it, they validate it, they deploy it, and they run it. Something happens in the middle of the night, they get up to fix it. They are responding to production issues. If it gets too expensive, they are responsible for that cost, not I. They have done something that makes their server load ridiculously high in their code. I can't fix that. I don't know their code. They know their code. Therefore, it is their responsibility to fix. We do have a central cloud services team. It's varied over time, 5 to 7 people or so. What the central service team owns are basically the cross-cutting concerns. Everybody cares about metrics, monitoring, and alerting. We don't need each dev team to come up with their own solution to that. We have a central services team to do that. We try to basically propagate good practices across the business. We create composable components. So rather than saying, thou shalt use my server, I will allocate it for you. We say, here's a package, install this. I don't care how you install it. You can use Packer to pre-bake an image and come out of the box. You can use Chef to automatically put it on. You can use your own automation tools, whatever. Here's a package. And this goes along with it is their responsibility to run it. I'm offering them services. I don't require a whole lot of them. The company requires a whole lot of them. but they're not accountable to me, they're accountable to the general manager. I help them meet their responsibilities. The Central Services team also has the job of being the cloud experts. Something weird's going on. Come talk to us. And something weird can range from not very weird at all of, hey, I've heard about this cool Lambda thing. How do I use that? What's that about? To, wow, you know, every night around 12:30, we see a 4-second delay in network communications, and it really messes with a quorum algorithm on our cluster. Well, yeah, that's a fun one. Thing is, all these developers are used to playing in the cloud, and they're responsible for a lot of things, so they're good at it too. The cloud ops team is not necessarily the most knowledgeable in the company. We have the scope to be, but they're really good. So that results in lots of conversations. They'll involve the cloud op team, but it's not necessarily ours to solve it or even ours to have the good ideas. It's a very cooperative process. Other thing that Cloud Ops does is automate everything that is not project specific. New Amazon account creation, new user account creation, VPC setup, security groups, everything. We have a set of standard bases. You can basically consider this the infrastructure that's owned by the Cloud Ops team. Now, it turns out we get a lot of very specific change requests from the developers, to the point where that presentation on GitHub was excellent, because we use GitHub. And we use infrastructure as code, or I guess vice versa. And so often when a developer asks us to change something, they actually submit us a pull request saying, this is how I would like this changed. Hey, great, this sounds like a great idea. We'll go apply it to all of the accounts now. It is very important, as you've picked up from what I'm saying so far, to align authority and responsibility. If I'm responsible for something I can't fix, that doesn't work. Vice versa. If I can fix it, but I don't have the responsibility for it, I might not care. When my manager is hammering on me to get something done, and somebody comes and says, hey, this is really important, you know, my game's going to die tomorrow unless you do this, and my manager doesn't care, it's hard for me to care. That's a lot of what we do, is getting that right, getting that well aligned, so that people can do their jobs and get things done. As I mentioned, if Dev is getting up in the middle of the night to fix something, they have the full power to fix it now. Flip side, if something breaks in production and I don't have the power to influence it, I don't get up in the middle of the night. I don't get called. I'm actually on the escalation path about I think 2 or 3 levels up, so if they don't get up and fix it, then I will be getting up to find out who needs to fix it. But we want the information, the notification to go to people who have power to fix it. Related note, that means the developers get a great deal of control over what goes out. Here's an awesome new metrics package. Great, we're going to put it in QA first to make sure you're not messing everything up for us. And that makes a lot of sense, because it's their responsibility to get up in the middle of the night if something breaks. So I think if there's 2 things to take away from this, I should probably wait to summarize later, but if there's 2 things to take away from this, you need to align the responsibility and the authority, and put that responsibility in the hands of people who can actually execute on it. How do we do all of this? It's confusing, it's herding cats. Developers also have their managers pounding on their heads for things. One critical tool we have is a rules and automated workflow engine. We have custom developed this system. Considered open source. Is actually a product from my consulting company, or it's actually a project from my consulting company. Considered open sourcing this. AWS config gets you some of this, gets you the rules part, but the real key is the workflow. The rules, in our case, are small, stateless snippets of Python code. Somebody just writes a little bit, it gets applied to every instance, and says, hey, let me check this thing about this instance. These rules, we can publish, the whole company looks at it. There's nothing hidden here. They check out this code, give us pull requests on it. We love that. Workflows are what the rules start. So an instance does not comply with something. We'll start a workflow to make it comply. Workflows are potentially long-running. They have state, which rules do not. They can trigger a bunch of changes. As an example, your instance does not comply. What happens? Well, you get emailed about it. What if you ignore the email? Well, I'll email you again in 2 days. Actually, I won't. The workflow will email you again in 2 days. You still ignore it. 2 days later, it emails you again with your final warning. And then it kills your instance. Because it didn't comply, and you didn't care enough about it to make it comply. This is not something I had to do. I did not have to read a report. I did not have to send you emails. I have a minion to do this for me. What I have to do is write the policies, write the workflows to make this happen. And yeah, by the way, we do have the rule that you don't just automatically kill anything that's in production. You can only kill things in dev and QA. If it's dying in production, it has to have an actual human saying, yes, this is a good idea, I approve. So as you might have noticed, this is a very powerful tool. The runtime is highly privileged and kept well away from everybody. This tool has the capability to destroy your entire world. It has God privileges over all of your accounts, because it has to do its job. But it actually keeps things running efficiently. And we have not actually destroyed the entire world yet, or even come close to it, I'm very pleased to say. If you did destroy the entire world, you have automation to put it back, right? As an aside here, it was not this tool that caused it, but one of the dev team's automation systems hit a condition that they did not fully consider and decided it was a good idea to delete all of production. This was during the initial release of the game. And the good thing here is their automation was such that as soon as they noticed it and finished facepalming, they hit the right switch, which caused that tool to put all of production back within 20 minutes without losing any of the state that it accumulated. Automation is amazing stuff. How do we do user access control? I mentioned I'm a bit of a heretic here. I'm not trying to get absolute least privilege correct. Automate user management, user creation from source checked into Git. Again, we can do PRs on this. We can QA this. We can try it out in a test environment before it hits something live. We can roll back. We define membership in a group based on some rules. It can be the intersection of, hey, I want to be a full admin, I can do everything. But I haven't defined any type of multi-factor authentication token in my cloud environment. And that means that somebody from the Ukraine just logged in as me and took down my entire system. That's bad. So, no, I'm sorry, until you have MFA, you can't be a full admin. This means that, again, the rules and workflows can enforce you have to have an MFA token. I don't have to. I don't have to try to configure Amazon to enforce that for me. I don't have to manage tokens. I simply say, until you've correctly associated a token and verified it, you can't do anything for it. And if you then later, you come out of the gate complying, but then you decide to change it later to make your life easier, oh, nope, sorry, you got demoted back to user. This is not just a one-time thing. This is a continuously applied policy. I was playing around with the Amazon IAM policies, trying to replace this with a policy that just worked. Looks like you can get about 60% there. It works pretty well for the resources it works for, and there are some others that just ignore the conditions, and therefore you can't write a policy that requires an MFA at the Amazon level. So this, as of today, they might release something again next week, but as of today, this is the way you would do that. So again, not trying for least privilege, not going to get it right. We divide our users into 6 categories. A basic user means you can log in, I know who you are. The only thing you can really do is manipulate your MFA token. Your next level up is read-only. That means you're probably a manager. You're not allowed to change anything. We have a finance group. They care about how much things cost, oddly enough. They're also not allowed to change anything. They care that much about how much things cost. They talk to a developer who changes something. Then we have developers. They won't talk to developers. They'll talk to a development team. Developers basically have privileges for dev and QA. These are people that theoretically don't touch production. The dev team is responsible for that production. That doesn't mean the manager of that dev team is going to give everybody on that dev team responsibility and authority to touch production. They may have some that are just devs. I also have a dev team that everybody on that team can touch production. That's the DevOps level. That's basically everything outside of infrastructure you can control. If you want to destroy your entire game, delete all of your volumes, all of your S3 buckets, all of your state, you can do that. It's on you. Here's the gun, there's your foot. You should probably try to miss that. And last, we have full admin. That's basically the cloud ops team, and that is the infrastructure level. Developers, DevOps, do not have the authority typically to create new virtual private data centers, new networks. They do not have the privileges to link those networks to the central services network, things like that. That's reserved for full admin. That's something they don't typically need to do when they get a wild hair at 2 in the morning about the next latest and greatest game. In the future, how are we going to do this? We've actually looked into a number of different ways, federating user access control, doing some type of single sign-on. The short form is all this is possible and has never been sufficiently important for us to solve. So we haven't done it. We've gone with what we're currently using. We'll probably end up with some type of SAML solution. We might integrate with AD. As soon as we start talking about AD, then wow, we get into an entire another group at the corporate IT level. And those are some very interesting conversations. One of the conversations, of course, is, hey, if we discover that a developer actually needs to be DevOps in the middle of the night to fix a problem, who in corporate IT do they call up to get that permission changed right now because users are down? And it's the middle of the night in the US, and that means it's gaming time in Australia. Network access control, we do have some standards around these, and these are much more at the full admin level of the central cloud services team. You VPN into the environments. We have Bastion hosts that you can SSH proxy or things like that. We have a lot of private VPCs, which means they're not reachable directly from the outside. We have shared root keys on all our servers. Yes, shared. That means the current best practice recommendations, oh my God, you should never share a root key. These are cattle, not cats. People don't log into them unless there's a problem. It's one of the DevOps guys trying to solve their problem. We actually have one team that just got to the point where they believe they don't even have to have Amazon console access. They're never going to have to touch anything outside of their automation. We don't, as I mentioned, do user management on individual nodes. Once I'm talking about an individual node, I'm not trying to blame a specific person for doing so. Cost control. This is a fun part of cloud. Cost control is definitely a big thing. Developers take the very rational and reasonable approach of, I need a faster machine. I need more machines. Hey, that machine might have something important on it, so I better not turn it off. 10 years ago, this meant you bought another machine in the data center and you're somewhere between 2-week and 6-month purchasing cycle, depending on the level, the size of your company, kind of gated what the developers could spend and they have to justify it. Now they click 5 buttons and they have a new machine that's all of a sudden costing you $2 an hour. $2 an hour adds up. It is important when herding these cats to consider costs, to make it one of your initial focus areas, and to continually monitor and manage it. So let's talk about specifically how we do this. This gets into the kind of the nitty-gritty of this is something you could do to improve things now on cloud. We have a tagging policy on every resource that costs us money. We must have 3 tags. Who owns it? What environment is in, what's it contributing to, and the project that it is part of, which is effectively a cost center. And one thing that we've learned, I'll call this out specifically, is do not use this project for automation. Do not allow developers to use this project for automation. Finance has a habit of occasionally changing their mind about how they want to track costs. And they change their mind, and I want to go back and tag the instances appropriately. And then developers go, oh, no, sorry, you can't. My automation depends on that tag. And so it's going to be a 3-month project to work that in. And it's their responsibility for running this. That's their call. Once upon a time, Amazon allowed you to have 10 tags. So I was already burning 30% of the tag space for these 3 things. They allow more now, so it's really not a problem. Have the developers use a 4th tag if they want to do automation. The reason these are 3 separate tags instead of 1 tag that expresses it, there are a number of interesting tools and services out there that can divide things up by tag, including some improvements in the last 6 months by Amazon. So having the separate tags is useful. We enforce tagging by the rules and workflow process. Remember when I was talking about killing instances? Well, if you don't have an owner, you're going to die quickly, because I don't even know who to complain to. So the theory is, I want to kill that instance before anybody has invested a significant amount of work in it. If you've got an owner, well, now I can whine for a while. Please tag me right. Please, please tag me right. Tag me right or you're going to die. Okay, that's it. You're going down. Had a manager about 6 months ago show up and say, great, we're ready now. Anything that's not tagged properly out of the gate, I want it dead in 5 minutes. This was a dev team manager saying this would be most efficient for his dev team to conform to our processes. So Cloud Health is one of those tools that we use to manage costs. It does some pretty good reporting, and it consumes those tags and allows me to make very interesting graphs and reports out of those tags to figure out where money is going. I also have a number of compliance reports that have been escalated to the general manager of the company, who ultimately can tell a dev team, no, I don't care, make sure it's tagged properly, because my CFO keeps chewing on my ear about this. And he's not going to shut up until you do this work, so you're going to go do this work now. Ultimately, that's what it takes if you don't have people understanding the importance of cost control. What you care about with Amazon specifically, one, the big one is reserved instances. And by the way, these slides are not just drawn from my experience, but I've gone to some presentations from some other substantial deployments. Specifically, at reInvent last year, Atlassian had a presentation that I pretty much laughed through 45 minutes of because it sounded like I worked there. And I hadn't. They had pretty much the exact same experience. They came up with the exact same 3 tags. They called their project tag something else, but it was the same meaning. So 80% of your instances which are on constantly should be covered by a instance reservation somewhere. This is an interesting thing. Why not 100%? You want to leave yourself some room to optimize, make things better. A lot of times people will question, well, do we really need that instance? I don't know. The dev teams knows. But I can tell you that that instance has been there for 6 months. In my experience, unless you know you have a short-term project. This is a proof of concept that's going to die in 2 months. Except for those cases, you can pretty much assume that 80% of your instances will live. And the way it works at Amazon is you buy a reservation for a certain type of instance, not a specific instance. So if that one doesn't continue to live, another one will probably take its place. And you don't have to pay up front for these. You can do no upfront reservations, which saves you almost exactly the same amount of money. So that's a big one. Turn off development systems overnight. This is much smaller, but it still saves you a noticeable amount of money. Particularly, this is not something we've done yet, but if you combine an automation for that with, Amazon now has scheduled reserves. So I can reserve something from 8 to 8 Monday through Friday, and then I can automate it so that it gets turned off at 8 and turned back on at 8. The developer comes in the morning, their system's still running, ready to go. Obviously, if they have a debugging session, they've lost that. This is one of those things where I said there are always exceptions. This is an exception, and a developer can actually tag their instances, no, I really need this. Of course, then I can expose that in the report, and they've got to justify for the general manager, really, you really need $2,000 a month of instances that are always on in your dev environment. Not production, dev. We can make those distinctions now. $2,000 doesn't sound like a whole lot, but it's a lot of pizza money for the developers. Stay on current generation instances. I'm sure this spans cloud providers. Basically, you get better performance per dollar. It's a small optimization. The big resistance you have is, oh no, it's working now, I can't change it. And that actually points to lack of automation. That means I'm afraid of it. I'm afraid of changing it. Great, here's my next question. What happens when it breaks at 2 in the morning? How do we get it up? If you're so afraid to change it while all of your staff is awake, fully caffeinated, and ready to do it, what happens if it goes down in the middle of the night? Pay attention to network traffic. You can buy reservations for instances, you can't buy reservations for network traffic. You can't buy reservations for storage. If you want to hear a horror story, let's discuss a 72-node Mongo cluster doing replication between AZs at 1 cent per gigabyte. That gets pricey. Do cost estimates. It should be early on. Your cost estimates are different than they used to be. My cost estimates used to be, I need 20 machines. Now my cost estimates are, I need this much compute. I might do that for big machines, 20 small machines. I care about that. I care about traffic, users. That's how I'm doing my cost estimates now. Have guidelines. Remember that they're only guidelines. Different project comes out, it's got different requirements, it's got a different architecture. It might very well have different cost estimates. You cannot apply the same guidelines. But you can have the discussions about it. And that's what's really important, is to have those discussions early on. How do we actually herd the cats? One thing we found that worked very well is we created a DevOps working group. This is basically senior engineers from all the teams. There were no managers in this group. And that was the explicit rule that I had to tell the managers. If you can't lay your hands on a keyboard, and by the way, you're in the read-only group, so you can't. If you can't fix a problem, you can't come to this group. You can think about this if you are up late on the History Channel watching the history of Toyota and their TQM initiatives in the 70s. They would get a whole bunch of line production people around and talk about how to improve the line. It's basically the same concept. We get people who actually solve the problems saying, what problems do you have? And let's solve them. We can identify cross-cutting needs here. Oh, look, this development team said something. Those two chimed in that they have a very similar problem. Hey, let's solve that in one place instead of 3 places. So typically for us, this group was one representative from each dev team and all of the cloud ops team. Because we wanted to be there listening to our customers telling us what they need. The Cloud Ops team itself is about half of the service organization and half the owner. So a lot of what we do is, no, that's a bad idea, you can't do that, here's why. And a lot of what we do is, okay, I hear you, and they need that too, or we're getting in the way, we need to fix this for you. So it's an interesting dichotomy there. You have to have good relationships with your cats. If you tick off the cats, they will just go away and ignore you. The DevOps working group gets awfully sparse, nothing actually happens, it's a giant waste of time. You have to maintain a good relationship. And your cats are your scouts. They actually encounter the requirements way before your central team does, and they're your customers. They're responsible for it, not I. So they tell me what they need to meet their responsibilities. Listen to your cats. If they're purring, that's probably good. The results of all this, there are pros, there are cons. Looks like a longer list of cons, but the pros are actually much larger. The pros, we really maximize our development velocity and our agility. We need to do another project, I can spin up that environment and have it going tomorrow. All the machines you need, all the networking, all the environment, we're good to go. That's really nice. It is actually people scalable. It's also machine scalable. So that's also really nice. You can try out different working patterns. We have different dev teams doing it different ways. We lay requirements on them. You have to meet these production standards. How you meet those is different. And then I can say, hey, Team A, Team B is doing something really cool over here. You might want to take a look at that. Cons. Hey, you've got different dev teams. They're doing different things. They're not the same. That means I have to care about that. It does get a little bit of inconsistent. Again, careful about responsibility. I need to make sure authority and responsibility always match. You're always going to have some weeds in the garden, something that doesn't work out quite right. Not a problem unless your garden is overrun with weeds. You're always trying to keep up with your developers. They're always ahead of you. On the other hand, this is always true. I have yet to see an environment where it's not true. What I've seen is a lot of environments where people don't realize it's true. In this environment, you at least know it, and you're not getting in the way of them producing code, fixing problems. Some resources you might want to use for Amazon, for a substantial installation, substantial deployment, AWS enterprise support. They're pricey, but they are worth it. They basically give you access to people who care about you, care about your technology, learn what you're doing and learn what you care about. And it's awfully nice to get a call from them saying, hey, we've got this new thing coming up that you care about, and I know this. It's also awfully nice to be able to call them and say, I have this weird problem. Go knock down whatever doors you need within Amazon to help me fix my problem. You pretty much have to pay for enterprise level support to get that level. It is useful. There are a lot of cloud-based services, a lot of options, and their primary advantage is their operating expense rather than capital expense. Their other advantage is they tend to be priced based on your scale. There are still some older companies that are trying to price the way they used to 10 years ago. Most of the newer companies, for example, metrics, I go to Librado, they'd say, great, pay me 10 cents per metric that you collect at a 60-second interval. Okay, I collect twice as many metrics, I pay them twice as much. I chop it down, collect half as many metrics, I pay them half as much. I don't have to worry about negotiating, signing long-term contracts, it's just utility-based pricing. I don't have to spend it up front. Again, you care about your costs. You want some sort of cost exploration tool. AWS Cost Explorer, AWS Billing is getting jobs that need to run periodically. I need to update this. I need to start that. I need to run this thing. That's all done in a Jenkins installation. It's open source, it's easy, it gives me a nice web UI, I can produce the artifacts, and when the manager says, hey, when did that last run? I can send them a link to the web page. Here, knock yourself out, don't bother me, I'm doing it. Chef, likewise Puppet, we actually don't use very much anymore. Because of the heavy investment in Docker, we don't care that much about our host nodes. Once upon a time, I cared a great deal about this configuration. I spent a lot of time playing with Puppet. This particular company had an investment in Chef. Don't care anymore when I'm based on CoreOS. There's nothing I can configure anyway. Docker takes care of a lot of that configuration control and actually allows me to not have to apply that to live machines. So if something goes wrong with it, you know, it's kind of always built from scratch. If something goes wrong, I detect it much earlier than, oh, one of my production nodes just went down because Etsy password just went read-only. Yes, I've had that happen. We've done this for a while. We've learned a lot. What are we doing next? One thing I would love to do is the concept of cloud service liaisons. This company is pretty much invested in agile development processes, specifically Scrum. And so I want to have a designated consistent member of the cloud team going to each team's sprint planning meetings. The rest of the process isn't that interesting, but the sprint planning allows us to figure out what's coming up, and so we can get ahead of it. Lunch and learns are always a great thing that we do not do enough of. This works both ways. The cloud ops team can present an interesting topic, or one of the members. We also get the developers, dev teams, can present an interesting technology or an interesting problem they're trying to solve. And it's good to just facilitate that communication. And the last thing is, I don't think we're ever going to hit the end of policy automation. You get to the big things, the next thing's the medium things. You know, once you finish those, you're going to hit the small things. Well, by that point, big things have changed. You need to fix that. We're just going to go on, and all that's going to do is improve our lives. Because all the things we need to care about or should be caring about, we get ahead and have the electronic minions care about for us. Some other lessons, start when you're small. Fixing this, retrofitting it after, is a lot more work than just doing it out of the gate. It's going to change. You don't have to get it all right out of the gate, but start the processes. Automate everything, even when you don't have to automate it. It has a lot of benefits. You know, there's an XKCD cartoon some years ago about what's it worth to automate. And you can make a very rational argument that, you know, this is only going to take me an hour to do, but 10 hours to automate. Yeah, but now I don't have to worry about it. And by the fifth time I did it, the ratio is a little bit different. So if you have a philosophy of, I'm going to automate it unless there's a really good reason not to, you get better results rather than using the opposite. Here's my theme. Put the power in the hands of the people who can actually make things better. That's how you get things better. If you don't do that, things don't get better. People naturally want to do the right thing. They want to make their lives easier. They want to do good things for the company they're working for. You can make that difficult or you can make that easy. And if you are leading a cloud initiative, or if you're in the cloud ops team, you have a lot of leverage over that. And you can use your powers for good or evil. Anyone have any questions? Are we using Docker Native or ECS? We're actually using Docker Native. Part of that is our investment in Docker started before ECS was anywhere near decent maturity. We're still ahead of ECS. Anything else? Okay. Incidentally, all of my cat pictures were on Google with free reuse, or Chris took them, or I took them. Thank you very much.
So once again, thank you for attending. If you're not a member of the VTUG Slack channel, hit me up, let me know. We've got some good channels for AWS discussions. I've been doing a lot of that recently with doing the AWS CSA Pro Cert. So let me know if you're not a member of the channel and want to go. Thanks so much.
You know, it's interesting. The next yeah, I mean, that's kind of the thing. I've heard. You already know that. I've heard that. That's a big thing to require. So I don't need to see all of that or anything.
Well, I was going to go to it only because there's stuff I never thought of. I'd rather spend time with Dewey.
Oh, yeah. I'll tell you something though. It's interesting. Hearing all this stuff and like I'm thinking about the stuff we do in this it's been very as a result of so much of the stuff that I had to do in my life. I have basically started creating a more or less self-contained